Picture this. You're standing in the African savannah, sun directly overhead, no shade for miles. There's an antelope about 200 yards ahead of you. It's faster than you, way faster. It could outrun a car for the first few seconds. You have no spear yet, no bow, nothing but your own two legs and a body full of water you can't afford to lose. And somehow, hours from now, that antelope is going to collapse in the dirt, and you're going to walk right up to it. Not because you're stronger, not because you're faster, because you never stopped. That's not a myth. That's not some exaggerated nature documentary moment. That's a real hunting strategy that real humans use for hundreds of thousands of years, and your body still carries every single adaptation that made it possible. You are right now, sitting there watching this video, built like a machine designed to run something into the ground until it simply can't run anymore. And the wild part, the answer for why goes way deeper than humans are good at cardio. Once you understand what your body is actually built to do, you're going to look at your own legs, your own sweat glands, even your own butt muscles, completely differently. Let's start with the obvious question. If a cheetah can outrun you in a straight line, easy, no contest, how on earth did slow, weak, clawless humans ever manage to catch anything? The answer is we cheated. Not with tools, not at first, we cheated with time. The heat trick. Here's the thing almost nobody thinks about. Most animals that can sprint faster than you cannot run for very long. A cheetah gasses out after less than a minute. An antelope can outrun you for a sprint. Sure, but if you keep chasing, without ever letting it fully rest, something breaks down, and that something is heat. A 2004 study published in Nature by biologist Dennis Bramble and paleoanthropologist Daniel Lieberman laid out something called the endurance running hypothesis, arguing that humans evolved a specific suite of traits purely for long-distance running, not walking, not sprinting, but sustained distance running over open terrain. Most four-legged animals cool themselves primarily by panting and running use the same muscles in the torso. You physically cannot pant efficiently while galloping at full speed for very long, which means an animal running from a human hunter is stuck in an impossible bind: sprint and overheat fast, or slow down and get caught. Humans don't have that problem, and that's where it gets interesting. The sweat thing. You have somewhere between 2 and 4 million sweat glands covering nearly your entire body. Almost no other mammal on Earth is built like this. Most animals that sweat at all only do it in small patches, paws, muzzles, places that barely make a dent in cooling a full-grown body. You, on the other hand, are basically a swamp cooler with legs. Research out of institutions studying comparative physiology has pointed out that this kind of full-body eccrine sweating lets humans dump heat continuously while still moving at a steady pace. No panting required. No slowing down required. You just keep jogging, keep sweating, keep cooling, mile after mile, while the animal you're chasing is quietly cooking from the inside. And it's not just the sweat. It's the fur, or rather, the lack of it. Somewhere in our evolutionary past, we lost most of our body hair and kept a dense mass of hair only on the head, likely to shield the brain from direct sun, while the rest of the body stayed exposed for heat dissipation. It's an oddly specific trade-off, and it lines up almost too perfectly with a species that spent its afternoons jogging prey animals into heat stroke. Some of you already knew the sweating thing. Maybe you've used "I sweat like nobody else" as a personality trait at some point. And honestly, evolutionarily, you were bragging about the right thing. The legs are a machine. Now let's talk about what's actually happening below your waist, because this is where it stops being neat and starts being borderline unsettling in how specifically engineered it all looks. Your Achilles tendon is disproportionately long and springy compared to other primates. Chimpanzees, our closest living relatives, have a short, stiff Achilles tendon that's basically useless for storing energy. Yours acts like a literal spring, stretching and recoiling with every stride, returning a significant chunk of the energy you put into each step. Lieberman's research team estimated that this kind of elastic energy storage in the leg tendons and arch of the foot can cut the metabolic cost of running by a meaningful percentage compared to a leg without that spring mechanism. That's not a small tweak. That's the difference between a run being exhausting in a mile and being sustainable for hours. Then there's your glutes. Your gluteus maximus, the big muscle in your butt, barely does anything when you're walking at a normal pace. The electromyography studies going back decades have shown it stays relatively quiet during walking and only fires hard during running, especially when your body pitches forward and needs to stabilize the trunk with every stride. Chimpanzees have small, flat glutes. You have some of the largest gluteal muscles relative to body size of any primate on the planet. And they only really turn on when you're doing the one thing chimps basically can't do well, which is run long distances on two legs without falling over. Even your inner ear got involved. The semicircular canals, the tiny fluid-filled loops responsible for your balance, are larger in humans relative to our body size than in other apes, which researchers have linked to the head-stabilizing demands of running, not walking. Somebody, somewhere in evolutionary time, needed you to keep your eyes locked on a target while your whole body was bouncing up and down at a fast rhythmic pace for hours, and your inner ear got upgraded specifically for that job. Put it all together and you get something strange. A body that's mediocre at almost every single physical skill except one very specific, very unglamorous one. You're not the fastest, you're not the strongest. You're not even a particularly great walker compared to some other animals built for efficient walking. But hand you a hot day and enough time, and you become one of the most relentless endurance machines evolution has ever produced. This isn't just theory, by the way. The people who never stopped doing it. Persistence hunting isn't some fossil-only behavior anthropologists reconstructed from bone shapes and guesswork. It's been directly observed, in living memory, among groups like the Sand People of the Kalahari Desert in Botswana and Namibia. Researchers, including Louise Liebenberg, who spent years documenting these hunts starting in the 1980s, recorded sand hunters tracking a kudu or eland under the brutal midday heat, jogging at a pace that seems almost lazy compared to a full sprint, but never letting the animal fully recover. The hunters read tracks in the sand, predict where a spooked animal will circle back to, cut distance with smarter routes instead of raw speed, and simply wait out the biology. 2 to 5 hours later, sometimes longer, the animal goes into hyperthermia, stumbles and stops. Liebenberg's accounts describe hunters walking up to animals that are still standing but too heat exhausted to flee anymore. Not a dramatic Hollywood chase. A quiet, patient, almost meditative war of attrition, and the human wins every time because the human was built to... Think back to that antelope from the start of this video. 200 yards ahead, faster than you in every single measurable way in the first 10 seconds. That gap was never the story. The story was always what happens at minute 40, minute 90, minute 210, when the antelope's body is fighting a battle against its own internal temperature and yours isn't. But here's the part that gets uncomfortable once you sit with it for a second. If your entire body, your tendons, your glutes, your sweat glands, your inner ear, all of it, was fine-tuned by evolution for one specific purpose, chasing something across open ground for hours at a time, then what happens when a species like that spends its entire life sitting in a chair? Because that's exactly what most of us do now. We built a world with zero persistence hunts in it. No antelope to chase, no heat war to win, no multi-hour pursuit demanding everything your legs and lungs evolved for. And your body did not get the memo that the job is over. It's still down there, quietly expecting a chase that never comes. Some researchers studying physical activity and chronic disease, including work referenced by evolutionary physiologists like Daniel Lieberman himself in later writing, have pointed to this exact mismatch. A body engineered for near-daily endurance exertion now living inside decades of near-total stillness, as part of what's driving modern rates of things like cardiovascular disease and metabolic dysfunction. It's not that exercise is some optional bonus feature for a modern lifestyle, it's that stillness itself might be the unnatural condition. The one your biology was never actually designed to handle. That's the uncomfortable layer under all of this. We spent generations being amazed that ancient humans could run down an antelope with nothing but sweat and stubbornness, and the whole time we've been sitting on the exact same hardware, just never turning it on. And maybe that's why running, real running, the kind that hurts for the first 10 minutes and then suddenly doesn't, feels weirdly good to so many people once they push through it. Not because it's punishment, because it's memory. Your Achilles tendon still remembers how to store that spring. Your glutes still know their one real job. Your sweat glands are still standing by, 2 to 4 million of them, waiting for a heat war that almost never comes anymore. So here's the thought I want to leave you with. Somewhere out there, hundreds of thousands of years ago, one of your ancestors stood in the heat, watching something fast and strong and terrified run away from them. And instead of giving up, they just started walking after it. Not sprinting, not panicking, just moving steadily, patiently, for hours, trusting a body that had no idea it was making history. That same body is yours right now. The tendons are still there. The glands are still there. The only thing missing is the chase. So the real question isn't whether you're built to run something down. You already are. The question is what you've been chasing instead, and whether it's worth the miles.